Hello everyone, this video is going to talk about how to set up and run a turbulent flame experiment in the hybrid flame analyzer. We're going to start from the very beginning to actually running the experiment. So everything's turned off right now. First thing we want to do is turn on our water cooling. So we're going to turn on the water cooling. We want to turn it on slowly at first. We want 10 liters a minute. And it takes a little while for the pressure to adjust in the system. Next thing we want to do is turn on the mass flow controllers. They require about 15 minutes to heat up, so we want to turn them on and let them get started. Go check that, it's a little low. So I'm going to rotate this towards you to increase the flow and towards the wall to decrease it. Then we want to plug in the power source for the main apparatus. It's this cord that goes to a power strip on the inside. We plug it in, then we want to turn on the fume hood power, the camera power, looks like that was already on, and the light power, or the fan for the light, and then this switch will turn on the bulb. If you're going to run the gas analysis, you'll turn on the heat sink, but we're not going to do that today. Then we're going to go in here and turn on our tank, turn on the tanks of gases. So we have 3 tanks, oxygen, or this is air, and I've been running these at 25 psi. Then we'll turn on the methane. This is lab grade methane. There's not an odorant in it, so you need to make sure you don't have a leak. Run this between 10 and 15 psi and turn on the oxygen. So this is pure oxygen. Obviously you don't want to mix very much of it with methane at a time. So I've been running the same pressure in the oxygen tank as in the methane tank because they combine for the pilot. So we turned on our 3 tanks. Now we need to open the valves to the tanks. So we come over here and we're going to turn on methane, which is the 3rd from the left, and air, which is the 1st from the left. And then we need to turn on our splitter valves because there's more than one person using this line, so we put in these splitter lines. So now we have the water cooling on, all the electronics on. We want to check and see if the combustion chamber is vacuumed out. I usually try and do it at the end. We want to look at the lens and see if there's, I'll zoom in on it, see if there's a lot of soot built up. So you can see soot building up on the first of the 2 biconvex lenses. So we're going, sorry for the shaky camera, I'm going to get a lens cleaner. So we're going to clean both sides, both the lens and the glass on the other side, to remove any soot. It's hard to do one-handed. Sorry about the camera movement. Maybe I'll black that part out. So we're just gonna, it's good to wipe in one direction rather than going back and forth. Just going to clean out the lens and the glass in front of the other lens so you have a clear line of sight to the camera. Now we did turn our camera on. We need to remove the lens cap and put on this shortwave filter. So the filter is kind of puttied onto this glass filter for the camera, so it screws onto the front of the camera lens. So just be careful not to drop it as you try and screw it on. Come on. Alright, so we have our camera set up. Next we need to set our flow meters to the right amount. So we have this, you'll have some matrix, some test matrix. Today I'm doing 35 liters per minute, which is the third turbulent intensity measurement. The 1 millimeter perforated plate is at position 6, and so for a phi of 0.8, my air needs to be set to 32.29. 32.2. See what I'm doing here. 29. And usually when I start, I open up the air and methane lines. Also, before we flow anything, we want to close the combustion chamber door. So to close the door, we have these clamps. We have pressure clamps on top and bottom. My dad calls them Destaco clamps, so I usually do 2, but they're really just pressure clamps. So I'll explain all the shutoff valves in the front in a minute, but we want to get the methane and air set. I usually just have the valves open when they're set, and then I'll close them. And so setting the air, the methane to 2.7. 2.712. Alright, so now that those are set, you'll see it takes a little while for it to come up to the set point, but then it's good to go. So now we have those flowing. We're going to turn them off because we don't want to fill the combustion chamber with combustible mixture. So first thing we want to do, we want to light the pilot. So before we light the pilot, we're gonna turn on the right side we have the main burner controls and the makeup air. On the left side we have the pilot CH4 on top and O2 on the bottom. So we turn on the makeup air. You can see it flowing. It's at 35 liters a minute right now, controlled by this rotometer or flow meter, whatever you want to call it. So to light the pilot, we're going to light when I turn on the methane line, we want 200 the cc's per minute. Now this is calibrated for air, so it's not actually flowing 200 cc's per minute of methane. Then we have a sparker. We're going to move that sparker close to the methane line. Sometimes it takes a while to get enough methane in there. There we go. The line is a bit long. Then we're going to turn on our oxygen, and we want about 700 cc's a minute of oxygen. And you can see you can hear it'll make a strange whining sound, but you can see the nice ring of pre-mixed methane oxygen fire there. Then we're going to turn on our burner air, and we'll see it. It'll take a second for the mass flow controller to adjust, because while its flow control is off, the mass flow controller will go to full open. And then we'll turn on our air, or our methane, the main methane line here. And so now we have our turbulent pre-mixed methane flame that's being held by the pilot flame. And then when we want to add our dust, so the dust we want is calculated in our test matrix. We want it to be 336. So we can see we have our feed rate set to 336 here. So to run this test, if you were just going to do the gas, pure gas, you take your pictures now. Normally I would do this first, but I'm going to run the dust just so you can see how it's done. I'm going to turn on, actually I'm not. I'm going to go ahead and take these images. How clean is that glass? Is that glass dirty? I think it's alright. So I'm going to turn on the light. See the pilot, or the shuttergraph light's now on. Then we have this camera control. It's set to a 35-second timer. So all we're going to do, start the timer, and then take 35-second worth of images. slow, talk amongst yourselves, talk amongst yourselves. While this is going, you can see the flame. 10 seconds left. Alright, then we're going to turn the timer off. And then we're going to turn the pilot light off. Or the shadow graph light off. Then we're going to shut off the methane line, the main burner line, the oxygen line, wait for it to extinguish, then the pilot line, wait for that to burn out. If you want to, you can just puff the main line and it'll blow out the pilot, and then shut off the makeup air. Now we want to light the pilot, the CH4, before we light the O2, because you'll get a small explosion if you have, or a small flash fire, let's say, if you light them both at the same time with the spark. So then we're going to have to wait for the images to be written to the camera. So while that's happening, we're going to make our file structure. So we have 1 millimeter perforated plate. It should actually be position 6. And then we'll copy the file naming structure from before. So we have 1 millimeter, it says position 1, I'm not going to change it now. F equal to 0.8, dust equal to 0 grams per meter cube, the bulk flow volume is 35 liters per minute. And then we'll copy all of our images in there. So we finished writing this. So we'll take this card out, put it in the flash card reader. This is just a compact flash disk. So stick it in there, and we'll get a little open to view files. View the files, select all of them, and copy them over. And then just check to make sure that you have the flame image here. It seems alright. So then we'll delete all the images off the compact flash drive. Wait for that to happen. Take a few seconds. So this is how I'm currently running the experiment. It's not necessarily the best way. The experiment may change. I make no guarantees this is the safest way to do things. If you do not know that it's safe, you should make it safe or figure out why it's safe. Safety is important. I'm not making any guarantees that if you follow these instructions explicitly that you won't mess up. So one of the main things we want to prevent is this main chamber from filling up with combustible products. So that's why we shut everything off before we leave it alone, and we turn the makeup air on first. So we have our makeup air flowing. We're going to run a dust test. Makeup air, pilot gas fuel, the methane. Use our sparker. 1 spark ignition, good job me. Turn on our oxygen. You'll see it flare up and then come back down to our mixture. Check the pilot. Make sure it's still at the right flow rate. Then we're going to turn on our main burner air, turn on our main burner methane, then we're going to turn on our dust supply and our pilot light. So we'll give it a few seconds just for the dust to kind of reach a steady state. Turn on our timer and start taking images. So the camera is set, currently the camera is set to a shutter speed of 1/8000 seconds, an ISO of 2.8, and an ISO of 800 and a f-stop of 2.8. So if you don't know what those means, I suggest you study up on DSLR usage, or you can look on firescience.com and there's a Visualizing Flames page. So then that's done. So that was 35 seconds with the images. We'll turn off our dust and turn off the pilot light, and then wait for this to write, make a new folder, copy all the images over, and continue this process. I'm going to turn this off while I'm talking. Continue this process until I'll do all 12 tests for each flow condition at one time, and then let the whole apparatus cool before I do another set. So I usually wear a respirator when I do this. I think I have all the leaks sealed, but I still do get a kind of a gravelly voice and some respiratory irritation if I don't wear a respirator, so I've gone to doing that. Once again, whenever you're doing experiments like this, especially combustion experiments, you need to know that it's safe. You can't just watch this video and say, okay, he's doing it like this, so obviously it's safe. I don't know what future changes are going to happen to the apparatus for the setup, so make sure that you're aware of what's going on and that it is in fact safe for your own safety. You can't just say, my advisor said to do it like this, because if you get hurt, it's you're the one who's hurt, so you want to prevent it as best you can. I hope you found this useful, and have a good day.